So, hi, we're Group 8 and our topic is Mediator Design Pattern. We have three members, me, Hưng, and Khả. This is our content where I would like to talk about the real world problem where we need to use a mediator and how the mediator works to solve the problem, some definitions and scenarios when you may need to use a pattern. Next, Hưng will show you the diagram and how to implement them in C++. Finally, Kat will talk about the pros and cons and all the related stuff. And to summarize what we have learned so far, we would like to have a small quiz. Hope you enjoy. For the real-world problem, I would like to use the airport as an example. It is one of the most suited scenarios where you need to use a mediator. So imagine there are many planes that need to arrive at the airport, but we don't have enough spaces for them. And our mission is figure out which flight is going to arrive next. And in naive solution, we can let them decide with each other. So if a plane wants to arrive first, we can ask other planes for the permission. And it is also the same for the others, but it may cause some major problems. First of all, is it may cost a lot of time for the planes to decide. Secondly, is it can cause confliction between the planes because many of them may want to arrive at the same time. And thirdly, it is hard to keep track of unexpected problems. And because there are a lot of connections between the flights, which is redundant, our system is completely a mess and may crash. So we need a mediator. Like its name, it promotes loose coupling by mediating the communications between the planes. The mediator is like the airport management. It controls the arriving and leaving of the planes. So the planes just need to ask the mediator whenever they want to arrive, and the mediator will arrange the time and the lane, and then tell the planes. So all the processes are much better, faster, and easier to keep track of certain problems. And come to the definition, mediator is one of the behavioral design patterns. It reduces the coupling between the components of a program by making them communicate indirectly through a special mediator object. And because the system now is not tightly connected like before, it makes the program easy to modify, extend, and reuse the individual components. Some scenarios when you may need to use the mediator design pattern. So the first one is when you find yourself creating a plethora of component subclasses just to reuse some basic behavior in different contexts. Because relationships between components are contained within the mediator, it's simple to define alternative means for these components to collaborate by adding additional mediator classes without needing to alter the components themselves. Secondly is when it's difficult to alter certain classes because they are closely connected to a slew of other classes. The mediator design pattern allows you to isolate the relationships between the classes into a new class, separating any changes to a single component from the rest of the components. And lastly is when you can reuse a component in another applications because it is too dependent on other components. So when you initialize the mediator, individual components become oblivious of the other components. They could still communicate with one another, although through a mediator item. If you want to reuse a component in another project, you must provide it with a new mediator class.
As we have know what are mediators and when to use them, now let's see how to use them. This is a general class diagram for the mediator design pattern. You can see component A, B, C, D are classes that contain some operations. Each component has a reference to the mediator. The mediator interface declares methods of communication with components, which usually include just a single notification method. And components may pass any context or arguments of this method, including their own object, but only in such a way that no coupling occurs between a receiving component and a sender class. Concrete mediator encapsulate relations between various components and often give references to all components they manage. As the current mediator here, you can see component A, component B, and component C and D. One thing to mention is that components must not be aware of other components. If something important happens within a component, it must only notify the mediator. When the mediator receives the notification, it can easily identify the sender, which might be just enough to decide what component should be triggered in return. And from a component's perspective, it all looks like a total black box. The sender doesn't know who ends up handling the request, and the receiver doesn't know who sent the request in the first place. This is the main concept of the mediator. And how can this be applied to our stated problems? Here is the class diagram for our stated problem. You can see the flight class and the runway class are the two components, and they are using the interface mediator. Furthermore, there's a concrete mediator named Airport Mediator that has multiple flights and runways covered in vectors. It also has some functions to implement the interface. So let's take a closer look at the mediator interface. There are two functions, is landing OK and set landing status, acts as the notify function in the general class diagram. And this is the correct mediator. We are using a vector of flights, runways, and a vector of Boolean values, which is used to save the availability of the runways. And whenever we want to add a flight or runway to the database, we will use register runway or register flight. And set landing status is a function used to set the status of a runway with index ID to a new status. And the last function in the mediator is landing OK. This is the main function of the button to communicate between a flight and a runway, and is often called by the flight to check the availability of a runway to make a decision to land or not. And finally, we will take a look at the flight class and the runway class. These will have their own constructor and attach the same mediator to each object. The land method in class flight will check the availability of the runway to land, while in runway class, land acts as a method to notify that the runway itself is free at the moment. On the client side, a mediator is created, which is used to attach to the components later. And we also create a new flight with ID group 8 and attach the created mediator to it. So we do the same with the new runway. And when a flight with ID group A wants to land, it will get ready and the mediator will check whether the runway is available at the moment or not and notify the flight to land.
Now we move on to the advantages and disadvantages of this design pattern. There are four main benefits of using Mediator. They are single responsibility principle, open-close principle, allow inheritance, and few subclasses. The first one, single responsibility principle, means that you can extracting the communication between the various components is possible under mediator method into a single place, which is easier to maintain. The next one, open-close principle, is easy to introduce new mediators without disturbing the existing client code. The third one, allow inheritance, is reuse the individual components of the mediators as it follow the inheritance. The last one, few subclasses. Mediator limits the subclassing as a mediator localizes the behavior that otherwise would be disturbed among several objects. On the other hand, the mediator design pattern has
three disadvantages. The first one, centralization. It completely centralizes the control because the mediator pattern traces the complexity of interaction for the complexity in the mediator. The next disadvantage is that a mediator can become a God object, which means it may know too much. The last disadvantage is the structure of the mediator object may become too complex if we put too much logic inside it. In addition, we will take a look at other applications of this design pattern. So another problem is in a chat application. When there are too many participants in a chat, we will have to deal with a loss of interaction of the participants with each other. So how can we deal with it? A naive solution is creating connection between each participant. But the problem with this solution is we will have to maintain a loss of connection. The more participants there are in a chat mean the more work we will have to do. This could cause harm to privacy and security. So the best solution is to create a mediator and connect it to all the participants. So when there are someone joining or leaving, we will have to maintain one connection, and all the participants will communicate with the mediator. The mediator will send the message to the one that the sender wants to message. The last problem is the portal problems. It's just like the previous one. We will also have a lot of connection to handle. The connection between each student and the connection between each courses, teacher, and connection between student and courses and teacher. And this also hard to maintain the connection if there are too many student, courses, and teacher. Therefore, we will use a mediator. We will connect the mediator to all the student, teachers, and courses. The mediator will receive the orders and will tell the student, teacher, and courses what to do. Finally, we will move on to the quiz. Let's start the quiz. The first question is, what is the main purpose of the mediator design pattern? The answer is to reduce communication complexity between multiple objects or classes. The second question, what's the disadvantage of mediator button? The correct answer is God object. Which of the following is true about design patterns? All of the answers are true, so the correct answer is all of them. The mediator button has which of the following advantages? The answer is all of them. which is not a real-world problem of Mediator. The answer is notify subscribers. This is the real-world problem of the observer design pattern, not the mediator design pattern. Next question is a true or false question. Abstract mediators are needed in single mediator classes. The answer is false. Explanation. As long as the college will only use one mediator, there is no need to build an abstract mediator class or an interface. Only if college needs to deal with different mediators does the notion of an abstract mediator become necessary. Move on to the next question. What design patterns is used as foundation of almost every GUI framework? The answer is the mediator design pattern. Last question. What is a mediator? Mediator is a behavior design pattern. That's it, the end of the quiz.
And it is also the end of our presentation. Bye.